today we want to find the value of x and y, given that you have x to the power of y minus y to the power of x equals 17. So now let's have it to the solution. Now from here you have x to the power of y minus y to the power of x equals 17. Now let's do this. Let's put them in bracket as x to the power of y minus in brackets y to the power of x equals 17. But here we can have it to be 1 and 1. But mind you that when you have 2 divided by 2, we believe that this will give us 1. So this implies that we can replace this one here as x to the power of y and to the power of 2 divided by 2 minus y to the power of x then to the power of 2 divided by 2 equals 17. So from here, according to the law of indices, when you have a to the power of m then to the power of n divided by n, this can be simplified as a to the power of m divided by n then in bracket all to the power of n. What we apply here, let us apply here. So it simply means that we can have this as x to the power of y divided by 2 then all to the power of 2 minus y to the power of x divided by 2 then all to the power of 2 equals 17. By taking this one here at this as this, then to the power of 2. Now let's do something reasonable by saying let a to be equals x to the power of y divided by 2 and b to be equals y to the power of x divided by 2. So which implies that it will change the look of our expression to be equals a square. From here the whole of this is a, the whole of this is b, then we have it to be minus b square equals 17. So now from here you have to recall from difference of 2 square, when you have a square minus b square always equals when you have a plus b then multiply by a minus b. So which implies that from here we have the whole of this here as a plus b then multiply by a minus b equals 17. So from here guys, let's think of the multiple of 17. We have it to be 1 times 17 or 17 multiplied by 1. So by having it here, we can have 1 times 17 or we can also have 17 multiplied by 1. But when we have this as a plus b at the left hand side and multiplied by a minus b, likewise this a plus b then multiplied by a minus b. Now from the left hand side, it is true that a plus b will be greater than a minus b because of this negative. No matter what the value of b may be, this a plus b will be greater than a minus b. So it is wrong to say a plus b equals 1. It is wrong because a plus b always greater than a minus b. So therefore we cannot consider this expression. So we consider this. Now by considering this one, we can equate it as a plus b equals 17 as equals to 1, and again a minus b equals 1 as equals to 2. By solving question 1 and 2 simultaneously, then add this one, we have it to be 2a. This will cancel this, equals 1 plus 17 will give us what? 18. So from here, by dividing both sides by 2, when we divide both sides by 2, we have this to cancel this. We have our a to be equals 18 divided by 2 give us 9. So when we have our a to be equals 9, we can also get the value of b by considering a plus b equals 17. When a equals 9, we have 9 plus b equals 17. And from here, we have our b to be equals 17 minus 9. And b equals what? 8. So we have our b to be equals 8. But let us recall that we have a and b from here. A and b to be equals this, and a equals this, and b equals this. So now from here we have our a to be equals 9, and we have our b to be equals 8. But when we recall, we have our a to be equals x to the power of y divided by 2. And so from here, this implies that we have x to the power of y divided by 2 equals 9. Now to eliminate this 2, we can take the square of both sides as x to the power of y divided by 2 all square equals 9 square. And so this will cancel this. We have x to the power of y will be equals 81. But mind you, when we have x to the power of y as this, we can also have 81 as 3 to the power of 4. And so obviously from here we can equate our x to be equals 3 and y equals 4. But before that, let's also consider this. Let's also consider this. We have b to be equals 8, and we have y to the power of x divided by 2 equals 8. Now to eliminate this 2 here, we can square both sides as y to the power of x divided by 2 all to the power of 2 equals 8 to the power of 2. Then we have this, we cancel this. We have y to the power of s equals 64. And so from here we have y to the power of x equals, we can re-express 64 as 4 to the power of 3. So by equating this from here, we have also y to be equals 4, then x to be equals 3. Now, mere looking at this, we have s to be 3. We also have it to be 3 here, y to be 4, y to be 4. So we can declare finally that our s equals 3, then our y equals 4. Now to check. Now we have x to the power of y minus y to the power of x to be equals 17. Now when x equals 3, y equals 4. So we have here to be 3 to the power of 4 minus 4 to the power of 3 equals 17. Or is it going to give us 17? So from here you have 3 to the power of 4 will give us 81 minus 4 to the power of 3 will give us 64. Then is it going to give us 17? Now, from here, this is impossible. When we borrow 1 from here, add to this one 2. From 2 minus 12 minus this one, we have it to be 11 minus this one, we have it to be 7. Then 7 minus this one, we have it to be 17, which equals 17. So this is true for the value of x equals 3 and y equals 4. And here are the steps. If you find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more mathematics tutorial videos. Here are the steps.